Hi, everyone. Thank you for having us. We are Compute for AI-driven analytics. That is what our company does, and I'll get into that more in detail in the presentation. The company was founded by Vikram Joshi a couple years ago, and Vikram was the lead engineer on Oracle's Exadata product back in the day, worked with Andy Bechtolsheim at Sun Microsystems and Silicon Graphics, and this is now his fourth startup as an entrepreneur. And what he wanted to do with this company was really do something game-changing for the future of analytics and AI combined. And that's what he's come up with as a product. He's baked it with early customers. We've tested it in the market. So this is sort of a beyond an MVP stage product. And that's where we are today. The mission is to unlock the full power, I'm reading here, of billions of underutilized processors for AI-driven applications. And how we do this is to provide unlimited concurrency, and we're seeing a 10x performance and a 5x cost reduction for complex compute. Complex compute is what runs analytics and also what AI analytics is going to be driving in the future. So there's a huge pain point now, but the pain point is only going to increase by 1,000 times in the future. And just to underscore, what we're seeing, 10x performance and 5x cost reduction at the same time, that's a 50x improvement over what's currently available on the market in price performance. So this is not a small thing. This is changing the future of compute as we see it. The problem today is that legacy infrastructure is inefficient. We're seeing 30% CPU utilization, or 7 in every 10 CPU cores are idle. They're just not being used at all. They're stalling out. We're seeing massive memory over provisioning. People are purchasing and integrating into their in-memory systems between 10 and 100 times more memory than is actually needed to run the analytics. We have data processing that could be on the low end about 10x more efficient than it is in both dollars and energy, so watts dissipated. And we're seeing data processing, including AI/ML on GPUs. It's increasingly being demanded for edge devices. So we know this is the autonomous system showcase. There's an application for the edge. There's also an application for the cloud. This is not pigeonholed into one or the other area. Really, this problem of CPU underutilization is everywhere. So what we've built is a next generation compute platform for edge and cloud applications, which dramatically increases efficiency and performance. We do this by using 80% fewer resources required. And one of the keys here is not over provisioning memory, as I mentioned before. If you're using the right amount of memory for the analytics, turns out you get to dramatically reduce the infrastructure footprint and the cost. We provide unlimited concurrency, which is at a minimum 10x faster than leading solutions. So concurrency is the relationship between performance and scale. As you scale out your users or your queries and business intelligence, you need more and more concurrency. And that's where today's systems start to drop off in terms of their performance. We are seeing steady performance with unlimited concurrency. You can scale from a single server to thousands of servers to hundreds of thousands of queries with minimal reduction in performance. We're solving open source challenges. So today's solutions on the open source market are promising in terms of creating data lakes and things like that, but they lack reliability. They lack ease of use, and the cost of human capital is fairly high. So oftentimes we're seeing companies trying to use open source, they have to hire a team of DevOps, or they have to hire a team of engineers, or they have to hire both. And our solution doesn't require that. And lastly, we have seamless integration and compatibility with existing analytics environments. The core behind our technology is really reimagining in-memory database architecture in order to fully utilize all the elements of the memory hierarchy. And we've done that using AI/ML algorithms to do vertical memory management. That means that if you need 1 gigabyte of memory 99% of the time, but if you need a terabyte of memory 1% of the time, our algorithm is able to read that in real time, just in time, and apply the workload to the appropriate elements within the vertical memory stack. As a result, we're able to run CPUs at 100% utilization all of the time. And we're able to do that on a dramatically reduced memory footprint, also leveraging SSDs for spill to disk. This is patented, so we have 2 patents and 2 patents pending, so 4 in total. But the real competitive advantage that we have and the competitive moat that we have is Vikram himself. This is something that only a handful of people in the world would be able to do, to rewrite database architecture from scratch. So what are the benefits? In cloud environments, in big analytics environments, we're seeing 10x performance, unlimited concurrency, and 1/5 the infrastructure. In edge environments, we're seeing high performance compute, so we can bring analytics to the edge in a way that hasn't been done before because we have that very small memory footprint that we require. We're also seeing 80% fewer watts dissipated. So the infra reduction is giving us energy savings for edge applications like self-driving cars and anything out in the field that are far above and beyond what anything is capable of today. So why now? I mean, it might seem obvious to you why now by the time I've come to this slide, but this problem of inefficient analytics is only getting worse by the day. So AI generated SQL is driving 1,000x more demand for this complex compute. And we're seeing it coming, today it's here, but it's going to be driven wholly more in the next couple of years. So AI powered business intelligence is one example. As you infuse AI into your Tableau or your Power BI solutions, that is generating machine generated SQL on the back end, which is complex compute. So it's just kind of spitting it out on the back end, and it needs infrastructure to support it. Low code and no code application development is another area of AI generated SQL, and then finally autonomous semantic layer generation. And if you don't know what that means, ask me later and I'll tell you, but creating a semantic layer to basically connect your data silos within any organization is necessary to drive business intelligence, decision intelligence, and that's going to be automated in the future. We're starting to see that today.
30-second warning.
Secondly, the DoD, this is just a quote straight from the Fog and Edge organization, but the DoD needs transformational compute technologies for onboard analytics to limit communications latency and costs, increase situational awareness, and provide energy efficient compute. I think this quote was made tailor-made just for our company because it's exactly where we fit. Here's an example of what the product can do in case study number 1, working with one of our early adopters. We were able to run 9 times faster with 4 users versus the existing Spark implementation, and we did it on 1/5 of the infrastructure cost. The reason why you don't see that bigger curve up here going to 6 users is because they were using an open source solution, and we couldn't actually get that to go to 6 users. So this is the concurrency example. It just failed, and that's what happens a lot of times in these environments. As you add concurrency, the jobs just start to fail. And that's all I have. The good news is that we slip into environments incredibly easily. We're non-disruptive to any sort of architecture infrastructure is there. The first use case is, so Snowflake is the 800-pound gorilla in the data analytics market. And we have a very easy way to deploy within 15 minutes or less into any cloud environment and run right alongside Snowflake. And the beauty of that is you can offload your transformations. So your ELT process, that's what consumes the most complex compute. And when you offload it to us, you can cut your bill in half or more. So Snowflake, the average customer in the Fortune 2000, we're targeting large customers, spends $1.5 million every year. And we can take that down to $750,000 immediately. So that's exactly who we're targeting. We have several customers in the funnel, in the pipeline, in various levels of discussions, POCs, demos, things like that. And we also have our early customers that have adopted and have tested the solution. But the good news is we have a direct selling motion that's working very well for the Fortune 2000 companies. I'm working with an advisor who is actually named the top sales guy in Utah, where I live, who's looking to come on board and drive that direct process. But we are also in conversations with several indirect partners who really want to sell us. So one of them is a federal VAR on the government side who looked at this and he says, this is something absolutely the government need. We want to sponsor you. We want to work with you and bring you into the federal space, which is great for me because I don't have a ton of experience selling to the government, but they do, so they're going to take us directly into the government. And then there are several other resellers and strategic customers who are interested in working with us. So we're in conversations with big name companies. We have 2 patents that have been issued currently. We have 2 patents that are pending. And we envision this to be eventually a 10 to 20 patent portfolio. We've hired one of the best patent attorneys on the planet, represented Silicon Valley firms in the past. So we have a good relationship there, and he's continuing to work on the patent portfolio.
Yeah, I had the #1 patent attorney who was the leading patent attorney at Oracle, where I used to work, considered the person behind databases, and which is the reason why we had very fast traction in getting this IP issued to us in such a short order. We are brick and mortar, CPU, memory architectures, and utilizing, so not looking at bio, photon, none of those things. It's feet on the ground. It's today's Intel, ARM, NVIDIA processors. What we really are doing, the most watts dissipated are through memory. So DRAM's keeping the RAS-CAS cycles out there, you dissipate the most watts. So we went after memory. How do you save on memory? You save on memory by looking at the data footprint and doing demand paging between memory and different tiers of memory, which are local. Even Intel has issued a new standard called CXL, where you can get large amounts of memory, but doing that has been very challenging. So we have thrown AI, ML algorithms. What's different is none of your traditional textbook algorithms work in this space, and we are able to condense the memory footprint, and we are also able to increase the performance as the complexity of the SQL and the queries and the data sets start to increase. That's what we're able to determine here. So the amount of memory is also how cloud costs of servers, as maybe preaching to the choir here. It's a direct function of not the cores, it's a function of memory. So going after memory, it reduces the infrastructure cost. And if you can reduce the amount of memory, for all the love that we've had for in-memory architectures for the last decade or so in analytics and databases, then there is something which is different. We believe this is fundamentally going to change the game. So very early there, testing it out.